you are part of the working group that Uwe Heiswolf is chairing, the EHEDG working group valves. Why did you decide to do that? To put your time in being a member of that group?
So, in fact, it's in the non. We really want to participate in this type of forums if we have this opportunity. And it's a moment that we can also share our difficulties and needs, but as well when we are in this type of working groups, it's very interesting because we have this cross functional, this different expertise in the background. And out of this discussion, everyone is able to influence each other, explain the different realities. And like this, we can really build a stronger and more real reality, you know, a real case for the users. We can strengthen the standards like that from an hygienic point of view.
Great. And Uwe, you being the chair of this working group, can you tell us just a bit about the stakeholders that are represented in that group?
In our working group, we have all the members of the working group are coming from the major valve manufacturers in Europe, and we are very happy about that. And we are also happy now that we have also some members from the food industry. So this will help us a little bit more that we prepare our work or our guidelines in a better way, so that we have always two sides contributing to our documents.
We see that there is a main difference also from your presentation between hygienic and non-hygienic seals. You mentioned that that is the most vulnerable part of the valve. So what is the difference between those seals shown in guideline 14? Because both of them are static O-ring seals, aren't they?
Let's say the non-hygienic O-ring seals corresponds more or less to the classic design, in which the O-ring is located in a circumferential rectangular groove. This design has narrow gaps that are very difficult to clean and almost impossible to clean. And the hygienic O-ring seal is located directly on the product area. It's almost completely embedded in the installation space, and there are no gaps left. There are only a relatively small opening to the product side, and it's easy to clean. And on the back side, there is some space left for to compensate thermal expansion, for example. And for most of all, this design allows the use of very small O-ring cord thickness,
which is better.
Yeah, of course, because when you look at the thermal expansion of the rubber material, for example, the smaller the sealing is, the better it is.
There are also developments, legal developments. For example, the new restrictions concerning the use of PFAS are, I think, very relevant when it comes to sealing and thus also for the valve design. Uwe, any thoughts on that new development?
Very difficult, because as a valve manufacturer, we have to rely on the sealing material which is available on the market. So we have to rely to the sealing producers. And so far, PFAS is a very, very huge topic. PFAS is plastics like PTFE. It's also rubbers like FKM, for example. So it's a bunch of materials which we used. And it's very difficult for us because we have to rely on this. And anyway, so far there are no materials which can substitute those PFAS materials. Katharina, what do you think about that?
Nightmare. Guys, we really, this type of materials that we are talking about, we use, for instance, in a very high heat zones, and they really bring durability to avoid leakages. And leakage, it's not about cost. Leakages is about preventing microcontaminations, and so this is why for us, the more durable seals will enable us to have a more safe production run. So again, I'm also a bit, we have to see what's at the outcome, because again, we need some other materials to replace these ones, because so otherwise we will have then to have more frequent shutdowns, more frequent maintenance. So we have to see what's coming out. It's very critical topic.
Uwe, next question is for you. How can we detect valve leakages in advance? before operation?
This is very, very, very difficult questions. Usually, you have your operational experience. You know about the lifetime. Usually, when we have a valve cluster, for example, we do not want to maintain the valve cluster during the regular production. So at least the lifetime of the sealing should be from plant shutdown to plant shutdown. It's all the shutdowns in between are downtime which are not calculated and which are not very helpful for the process. So at least what we do is we improve the sealings as far as possible. But you see, rubber material is stupid. There's no intelligence in rubber material. So if you would like to detect something, you have to prepare, you have to place a sensor inside, which is very difficult and which also increases the maintenance effort. So what we do is now, let's say, as Katharina said in her presentation, is that you have a maintenance logbook. You know exactly for this process, this is the average lifetime of the valve, and you plan your shutdown so that you never run into the problem that you have a leakage in between.
Exactly.
Right.
100%.
You agree, Katharina?
Yes.
If you want to
That's
add
why
something.
the maintenance moment, I call it the learning moment. It's a learning moment. It's telling you, giving you evidence if you are suitable, whatever you defined and selected, and the frequency is actually suitable to your reality. So thank you. It's really that.
Yes, I love that. The maintenance is the learning moment. That is a very different perspective to maintenance, I think. It's not a nuisance, but it's an opportunity to learn more about your process. The next question is actually about that. When you clean with CIP, how can you be sure that your valve is clean? How do you check the cleanability of it, the cleanliness? I guess many people are uncomfortable. They never know for sure until, of course, you get fluctuations in product quality. But question for both of you, I guess.
Verena, you first.
I will jump in because this is a very nice hot topic for us and for me in my function, in my profession as well. So we can know much more closer than we think, and it's about procedures. We need to ensure that we have a proper CAP validation plan. So if when we have a new installation, complete or partial installation, or installing something partially new or a full installation, we have to have some points that we are going to make inspections. And a valve, if we have a doubt of it's a new technology that we don't know, this will be what we call internally a key inspection point. So it means that we will have define a plan where we will have exposure to our product, to our running conditions, and we'll make swabbing. We can have some water collection in certain points, and we're going to learn. We are going to try to detect a deviation from what we have. So if we have a product residue present, so a cleaning validation is the only way you can actually not go from an empirical point of view, but from a reality point of view. So you have to plan, execute, and then you gain confidence. And if needed, you adjust your CAP program because that's as well. It's how you learn where you go.
Uwe?
Exactly. Yeah, exactly. It's for me, it's experience and proven in use design, and you know exactly where the valve works because no certification can tell you if the valve will be cleaned in a plant. Experience and proven in use design. This is something you can rely on.
Great. Not everything is AI. We still need the human touch here, like the human experience, which is great. Thank you very much. We're out of time and out of questions, so perfect timing. Uwe Heiswolf, Katharina Melo, thank you very much, and also your companies Danone and Kieselman for making the time and for your contribution to global food safety. We wish you much success and joy in the working group, and we thank you for this webinar. The recording of this webinar will be available on the EHEDG website. Thank you both.
Thank you.
Thank you very much.